Okay, number 7 on summary review number 1. We don't get any relief now on this particular problem as far as the LCDs because these two denominators in the numerator, it is a complex fraction because we have fractions in the numerator, in the top. They don't have any common factors, so basically they're what we call relatively prime. So basically our LCD is just this denominator times that denominator. So we have this pretty formidable LCD. Now when I multiply x squared plus h squared times x squared times this, the x plus h squares cancel, so I just have x squared. And then here I have, when I multiply this, the x squares cancel, and I just have x plus h squared. And then if I multiply this, I just multiply this out because I'm going to simplify it, so I want to save myself a line of work. So I just kind of wrote it down over here as x squared plus 2xh plus h squared. It's just a binomial squared, so we know that. And in the bottom, I have no help at all, so I have this whole shebang here, h times x plus h squared times x squared, and that's what I have there. Okay, then my next step is, since I've got this written, I can simplify this. So what I did was I had the negative sign, so I took an extra step here because I can think of this as in a parenthesis, so I've got negative x squared, negative 2xh, negative h squared, so just be careful. So that saved me one extra step because I would have put a parenthesis around this thing in an extra step, this trinomial, because I would be careful about not messing up one of these signs because the trinomial is preceded by a negative sign, which means all the three terms are affected. Okay? And the bottom is just that. Nothing's happening in the bottom. So the x squares cancel, so now I've got 2xh minus h squared, because those x squares canceled, and the same LCD. But what I do notice, I can factor out an h, and I also can factor out a negative sign because these both terms in the numerator have negatives, so I can factor out a negative and an h, and I can rewrite the numerator. And that's basically all I have is the numerator rewritten. But now I have a common factor of h, so as long as h isn't 0, which we know we've got to put a restriction on that, then this is what we have. Negative 2x plus h all over the x squared times x plus h squared. We just reverse those using the commutative property of multiplication. And we have to put restrictions on our domain. Well, we know that h can't be 0, we know that x can't be 0, and we know that this can't be 0. All right? Well, the only way that x plus h will be 0 is if x equals negative h, because that would be negative h plus h is 0, so we have to say that x can't be 0, and x cannot also be negative h, because that would make this 0, and then h can't be 0 because we've got an h over here in the denominator. So those are the restrictions on the domain. Okay? All right, let's take a look at the next one. And again, you can pause these, you can take a look at it, rewind it. So even though it may seem like I'm going fast, you can always stop it and kind of digest it to make sure you thoroughly understand these. Just basically just some good old Algebra 2. All right, let's take a look at number 8. And we'll just focus in on this part first. And again, these two denominators that appear in the numerator, which is what makes it a complex fraction, are relatively prime. They don't have any common factors, so I'm pretty stuck with this pretty formidable LCD, a trinomial times a binomial. Now, I'm not going to multiply those out. Okay, I'll just leave it like this, so I don't have to do that. That would be 6 terms. I don't have to deal with that. And then when I multiply this LCD times the first term, the trinomials cancel, so I've got x plus h times x plus 1, and I write it out. And then when I multiply the LCD times the second term in the numerator, the x plus 1's cancel, so I've got x, and it's negative x, don't forget that, negative x times the trinomial. And that's all over the LCD. H times x plus h plus 1 times x plus 1. And then I'll multiply these out carefully, don't forget the negative sign, and I can multiply this binomial out. So this binomial multiplies out to be x times x is x, x times 1 is x, I'm sorry, x times x is x squared, pardon me, x times 1 is x, hx, h times 1 is h, so I got 4 terms. And then I got negative x squared, negative xh, negative x, all over the LCD. And what happens is the x's cancel, and the xh and hx are the same, so those cancel, and the x's cancel. So there's 7 terms in the numerator, but 6 of them cancel, so I end up with just h. And what can I cancel? Well, I can cancel the h's as long as h isn't 0, and that's my answer. 1 over the trinomial times the binomial. Now I have restrictions on the domain. I know that h can't be 0. I know that x can't be -1. And I also know that this can't be 0. That means that if, in order for this trinomial to be 0, x plus h would have to be -1. So I can say that x plus h can't be -1. See, -1 plus 1 is 0. So I put this restriction here, and then I just put an inequality, and then I can solve for x by subtracting h, and there's my restriction there. So that's how they kind of deal with that. So you can take a look at that. I think everything's clear. Again, if you ever have any questions on any of these, email me and I'll try to, if you have concerns, you can put your concern in an email, and then I'll just do another video to address your concerns or questions on any aspect of these problems. Okay. All right, and last one we'll try is number 9, and this is a little bit easier than the last couple, so that's nice. Appreciate that. And but we do have radicals, so that makes it interesting. We do deal with these, especially when we're doing definitions of derivatives in the second chapter, I think, in our book. Okay, so I've got the square root of x minus 1 over 3 times the square root of x all over the square root of x. So I've got one fraction in the numerator, so that's my denominator, so that's going to be my LCD. So I just multiply the top and bottom by 3 times the square root of x. Now this is nice because when I multiply the square root of x times the square root of x, I just get x. And then these cancel, so I have -1. And then 3, and then the square root of x times the square root of x is just x, so I just have that. And you could leave it like that. For some reason, they separated this into 2 fractions, so they just wrote it like this. 3x over x minus 1 over 3x, and 3x over x is 1. Now the restrictions on the domain. Remember, for the square root of x, we can't take the square root of a negative number, and we can't have 0 in the denominator, so x must be greater than 0. It can't be equal to 0 because we have a 0 in the denominator. It can't be less than 0 because then we would have a imaginary number, a non-real number. We want to restrict these to real solutions. Okay.